So you may have heard of, or even played the game Tetris. Well, like a Tetris piece falling into place, drug molecules work by slotting themselves into these globby biological molecules called proteins. It's actually this fitting of one shape into another that triggers your medication's effects, be it lowering blood pressure or stopping pain. I am adapting this concept into a virtual reality game where the aim is to try and fit these drug shapes into protein grooves. The idea being that if players can find the molecular shapes that fit the proteins implicated in disease, then this could open the door to brand new drug treatments. So proteins are the tiny biological machines that keep your bodies operating and healthy. They're these long molecular strings that have folded themselves up into a globby ball, and this folded globby shape can be thought of as the blueprint for how these molecular machines work. Now, predicting how you go from molecular string to folded blueprint is a spatial task that we've always asked computers to solve for us, until now. You see, our brains are spatial awareness powerhouses, and we can easily outmatch a stream of zeros and ones, which is exactly why researchers in Washington decided to develop a protein folding game. And as it turns out, players of that game were more efficient than computers at solving protein folding, simply because we have spatial intuition and a computer doesn't. So it's a powerful idea, isn't it? Getting people to solve these biological spatial puzzles. Well, I want players to use this very same spatial intuition to fit drug shapes into proteins, just like slotting a Tetris piece into place. So to make my game, I am adapting Bristol-developed software called NanoSymbox, which shrinks the user down to the size of the molecules that make up me, you, this room, everything, and allows you to play and interact with them as if they were right in front of you. Now, NanoSymbox works with 3 different platforms, and to test them out, I asked 44 participants to take a short bit of molecular protein string and tie a knot on it. Pretty easy, right? And the eagle-eyed amongst you may have noticed that there are indeed 3 platforms on my slide, each of which has a score. That score is how many people managed the task on that platform. So in a nutshell, VR not only allows you to reach into the plane of the screen, it also perfectly tracks your hand movements, meaning the gestures required to tie a knot, or to do anything really, closely mirrors that of the real world. And apologies if you can't see the numbers on my slide, but VR's score was over 10 times that of the other 2, making it more powerful because it's just more spatially intuitive to use. So with these talks, I would ordinarily end with a video of NanoSymbox in action, but I do believe that would, technically speaking, disqualify me today. So I'm actually going to go one better for everyone here. NanoSymbox, including the knot tying task, can be downloaded and played. It's the link at the bottom of my slide. Thank you very much for listening today.